Hello friends, myself Vivek Sharma, working as an assistant professor, Department of Computer Science and IT, Arya College of Engineering and IT. So here today I am representing two parts of supervised learning, that is regression and classification. I am just giving some introduction or introductory part. Numerical part will be solved in further slides. So there are so many type of regressions we have already discussed in the supervised learning slides presentation. Here we are considering linear regression. As we know that linear regression is a statistical regression method which is used for predictive analysis. It is generally used where we have some continuous values, some real-time values. So it is the linear relationship between independent variables and the dependent variables, that is linear regression. If there is only one input variable, suppose we have only one input variable, then such linear regression is called simple linear regression. And if we have more than one input variable, then the type is known as multiple linear regression. So linear regression can be classified into two types, that is simple linear regression and multiple linear regression. Here we are taking some example, that is prediction of the salary of an employee on the basis of years of experience. So on the x-axis we are considering experiences, that is 0 year, 2 year, 4 year, 6 year, 8 year and 10 years onward, and on the basis of these we are predicting or prediction of the salary. So according to the experience, working year experience, how much salary he or she should have, that is we can calculate by the equation y equal ax plus b or y equal mx plus c. So here y equal dependent variable, or these are also known as target variable, whereas x is independent variables also known as predictor variables. A and b are nothing but that is linear coefficients. So in terms of real time entities, continuous entities, we can predict the values by using this model, that is linear regression. So here the linear regression model provides a sloped straight line representing the relationship between the variables. Mathematically, we can represent a linear regression as y equal a naught x plus a1 x plus some constant. So here the data points and the line of separation, that is known as line of regression. The values for x and y variables are training data sets for linear regression model representation. So here we have y equal, that is target variables, x equal predictor variables, a naught is nothing but that is intercept of the line. It always gives an additional degree of the freedom, and a1 is nothing but that is linear regression coefficient and also known as a scale factor of each input value, and here some constant that is for random errors. Now we talk about type of linear regression. So there are two type edges. If a single independent variable is used to predict the value of a numerical dependent variable, then it is known as simple linear regression. It means y tends to x. And in second case, if we have more than one independent variable which is used to predict the values of numerical dependent variable, like we have single target variable by using x1, x2 and so on. So there exist two type of regression lines, that is linear regression line, or it can be classified as positive linear relationship and negative linear relationship. A linear line showing the relationship between the dependent and independent variable. So if the dependent variable increases on the y-axis and independent variable increases on the x-axis, so here both of the values are increasing according to their axes. For example, x-axis and y-axis, the phenomena is known as positive linear relationship and the line is known as positive line of regression. In that case, we get the equation y equal a0x plus a1x plus some constant. Same as in negative linear relationship, if the dependent variable decreases on the y-axis and the independent variable increases on the x-axis, the relationship is known as negative linear relationship and the line is known as negative line of regression. The equation can be written as y equal minus a0 plus a1x plus some constant. Now the question arises, when we separate and when we segregate the data according to the line of separation, how we can find the best fit line. So our main goal is to find the best fit line. That means the error between predicted values and actual values should be minimized. The best fit line will have the least error. So to find best fit line, we check the distance from line. It should be minimum, means data points density must be maximum, that is near the line. We always check this by R square method, that is distance minus mean versus distance predicted minus m. R square method can be calculated by summation of y predicted minus y mean whole square upon summation of y minus y mean whole square. So it can be calculated according to the mathematical or numerical values. Real-time use, that is evaluating trends and sales estimates, analyzing the impact of prices changes, assessment of risk in financial services and insurance domain. How to calculate best fit line? That is the main phenomena when we calculate linear regression or we predict the output. So here we have two variables values x and y. For x we have 1 2 3 4 5 and for y we have some values 3 4 2 4 5. So here by plotting this we can see on the graph, we just point out all these values and here we are calculating mean for x, that is 3, and mean for y equal 3.6. We can see by this table we are just mentioning all the values. As we know that equation of regression line can be calculated as y equal mx plus c, where we can find the value of m by using the formula summation of x minus x mean into y minus y mean upon summation of x minus x mean ka whole square. So here in this table we are considering all the values for x, y, x minus x mean, y minus y mean. We have already calculated mean of x and mean of y. So by putting all the values x minus x mean, y minus y mean, and again in last two columns we are calculating x minus x mean whole square, x minus x mean into y minus y mean. So just by putting all these values we are getting the value of m, that is 0.4, and when we put this value we get the value of c, that is 2.4. So here we have the equation y equals 0.4x plus 2.4, that is the regression line. Now we have find the predicted value. So predicted value can be calculated by using the value of m, c, and for y, that is for given x, that is 1 2 3 4 5, we are just predicting values. So here we just putting all the values and we are getting some different values, that is first predicted value is 2.8, second is 3.2, third is 3.6, and last one is 4.0, 4.4. So when we plot all these values according to the coordinates, we find the best fit line. That is the way of calculating best fit line in linear regression. So the second type of regression is logistic regression. Logistic regression is nothing but, that is, it is used for categorical based data, and as we know that for categorical based data it is the part of classification. So logistic regression is one of the most popular machine learning algorithm which comes under the supervised learning, as it is used for predicting the categorical dependent variables using a given set of independent variables. Logistic regression predicts the output of the categorical dependent variable. Therefore, the outcome must be categorical or discrete value. It can be either no, yes, 0, 1, true, false, etc. But instead of giving the exact value, as 0 and 1, it gives the probabilistic values which lie always and always between 0 and 1. So logistic regression is much similar to linear regression, except that how they are used. Linear regression is used for solving regression problems, whereas logistic regression is used for solving the classification problems. In logistic regression, instead of fitting a regression line, we always fit an S-shaped logistic function which predicts two maximum values, 0 or 1. As I have already told you, it always lies from or between 0 and 1. The curve form from the logistic function indicates the likelihood of something, such as whether the cells are censorous or not, based on its weight, etc. Logistic regression can be used to classify the observations using the different types of data and can easily determine the most effective variables used for the classification. As logistic regression uses the concept of predictive modeling as regression, therefore it is called logistic regression, but it is used to classify the samples, therefore it falls under the classification algorithm. Here we are discussing logistic function, or it is known as sigmoid function. Here, as we can see, the values are lies between 0 and 1. Suppose we have value for y, that is target value 0.3 and 0.8. It can be shown as always and always. In logistic sigmoid function, there exists a value between 0 and 1. It can always be represented by threshold value, and it is the midpoint between 0 and 1. The value of threshold is always 0.5. The sigmoid function is a mathematical function used to map the predicted values to probabilities. It maps only real value into another value within a range of 0 and 1. In logistic regression, we use the concept of the threshold value, which defines the probability of either 0 or 1, such as values above the threshold value tends to 1 and a value below to the threshold value always tends to 0. The value of logistic regression must be between 0 and 1, which cannot go beyond this limit. So it forms a curve like the S form. The S form curve is called the sigmoid function or the logistic function. Here we are deriving the equation of logistic regression. As we know that the equation of a straight line can be written as y equal mx plus c, or y equal v naught plus v1 x1 plus v2 x2 plus up to vn of xn. In logistic regression, y can be between 0 and 1 only, as we know that always and always lies between 0 and 1. So for this we are dividing this equation by 1 minus y. By dividing 1 minus y, we are getting the values of y upon 1 minus y equals 0 for y equals 0 and infinity for y equal 1. So here we are getting the range from 0 to infinite. But as we know that our range must be minus infinite to infinite, so we are taking log of the equation. So finally we are having the equation log of y upon y minus 1 equal v naught plus v1 x1 plus up to vn xn. That is the final equation for the logistic regression. Here we have the type of logistic regressions. There are three types of logistic regressions. Number one, binomial logistic regression. Second, multinomial logistic regression, and the last one is ordinally logistic regression. So binomial logistic regression always suggests there can be only two possible types of dependent variables, such as 0 or 1, pass or fail. But we have three or more possible unordered type of dependent variables, such as cat, dogs or sheep. In that case, we use multinomial logistic regression. And the last one is, if we have there can be three or more possible ordered types of dependent variables, such as low, medium, high, or just opposite, high, medium, low, then we apply for ordinal logistic regression. So these all are the type of logistic regressions. Here we are considering some difference, that is between linear regression and logistic regression. As we know, linear regression is always used for continuous values, whereas logistic regression applied for categorical variables. Linear regression always solve regression problems, whereas logistic regression applies for classification problems. In case of linear regression, we get straight line curve, but in case of logistic regression, we have sigmoid curve or S curve. Real-time examples can be considered as weather predictions, classification problems, illness determinations, etc. Now, we are taking some problems, that is real-time problems. Suppose when we choose data set of Titanic and explore about the people, these who survived and those who did not survive. With today's technology, now we have the data. According to these data set, we apply type of regressions. And the second problem is a car company has released a new SUV in the market using the previous data about the sales of their SUVs. They want to predict the category of the people who might be interested in buying this or not. So according to the history and the data set, we define all the fields like user ID, gender, age, estimated salary, previous history of purchasing any car or not, whether he or she is interested or not. So these all are the conditions where a car company can survey and predict the output. So there was two type of problems, that is regression problem and classification problem. That was the introduction part regarding linear regression, logistic regression and classification. So in further slides we will discuss about numerical problems, numericals, that is based on other type of classifiers, other type of regressions. Thank you.